Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. I'd like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. Linode is sponsoring us this week. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual service for your next project. We are also sponsored by Sentry this week. Stop hoping your users will report bugs. Sentry's real-time tracking gives you insight into production deployments and information to reproduce and fix crashes. Check them out at getsentry.com and use the code podcastinit at sign-up to get a $50 credit. You can also visit our site to subscribe to our show, sign up for our newsletter, read the show notes, and get in touch. And to help other people find the show, you can leave a review on iTunes and tell your friends and coworkers. You can also join our community forum at discourse.pythonpodcast.com for your opportunity to find out about upcoming guests, suggest questions, and propose show ideas. Your host as usual is Tobias Macy, and today I'm interviewing Gunther Cox and Kevin Brown about Zorg, which is a Python framework for robotics and physical computing. So, Gunther, if you could start by introducing yourself.
So, my name is Gunther. I'm a computer science major, and Python is one of my primary interests as far as programming.
Great. And Kevin, how about you?
Hi, my name is Kevin Brown, and I am also a computer science major. And Python was not my initial programming language of choice, but it has now since become my programming language of choice.
How did you guys get introduced to Python? Gunther, how about you?
For me, it was a little bit just on my own, and then also a little bit through work.
And Kevin, how did you first come across Python?
I came across Python through work. I was assigned a project that required it, and I basically was given the option to learn it or take a different project, and I decided to try something new.
So, could you guys share a bit about what Zorg is and how it came to be?
Sure. So, originally, the idea to create Zorg came around when we were participating at a hackathon at the Hack UMass event at UMass Amherst. The idea initially came up after talking to a group of developers from Intel that had come to the event as sponsors, and they had mentioned how they had a lack of a Python implementation to work on their Intel Edison boards.
And what is it about the Edison that makes it a good platform for robotics?
So first off, there's a lot of very interesting features about the Intel Edison. What's nice is that it has multiprocessor architecture, so you can do some very interesting computing on it. You can do multiple things simultaneously. The other thing is that it has typical Unix environment that actually gives you the ability, to run fairly high-level commands and things like that that you don't have access to on development boards such as the Arduino and things like that.
One of the good things about the Intel Edison when we were working on it that really appealed to us is that unlike working with a couple of other development boards, the Intel Edison allowed for direct serial communication between the Intel Edison and your computer. So we didn't have to plug it into a monitor or find a TV or find a router to connect it to. We were able to directly work on it without any extra effort required, which made it really good for developing in a short period of time.
And when you say serial communication, you're talking about via an RS-232 port, or is this just via pure SSH?
It's through a RS-232 port that basically serves a terminal back to you through a TTY, which basically gives you the equivalent of an SSH without having to actually go through the protocol.
Yeah, I've spent more time than I would like at a RS-232 console for one of my previous jobs. So how would you define and differentiate the concepts of robotics, physical computing, and the Internet of Things?
So in my opinion, all of those topics are tied very closely together. I don't know if I'd necessarily differentiate all of them, but I'd say that it's more of a subset ecosystem. Is that you have the Internet of Things, which is a larger overarching category, and then physical computing, or actually physical computing and robotics are both kind of go hand in hand, but I'd say that robotics is more of a type of physical computing, and physical computing is just one component of the Internet of Things. Because the important thing to remember is that a lot of the devices that are out there, some of these aren't actually physical. You can have virtual machines running as well that processing information and feeding it back to your physical computing projects, which is kind of the cool thing about being able to use high-level languages like Python, it's because you can actually, leverage a lot of these tools very easily.
Yeah, it seems that a lot of the dialogue about the Internet of Things tends to focus more on sensors with a little bit of intelligence attached to them directly so that they can communicate their information wirelessly without having to have them wired directly into a separate piece of computational hardware. It seems that at least consumer robotics has taken off quite a bit lately with the advent of a lot of the different single-board computers and Arduino becoming more prevalent and somewhat more powerful. What are your thoughts on that?
So, I mean, it's definitely very interesting to see, how the wide availability of computing power is contributing back to what people are creating. Originally, a lot of the limitations of, boards like the Arduino and, basic stamp chips before that, a lot of the issues were, coming down to the fact that you were limited to only so much memory. But now that memory and processing power isn't such a huge issue, it's not holding back the ability for people to use high-level languages that let them use more features and abstraction than they would have been able to use before.
And would something like Zorg be useful in conjunction with, microcontroller boards powered by the MicroPython runtime, for instance?
We actually looked into that at one point. Kevin, if you want to...
Sure. So the MicroPython board, along with PyBoard, I believe it is, that goes alongside of it, is something I've actually looked into in the past for connecting to Zorg. As the advantage of it runs pure Python, and it also supports package management through pip, which is something that nicely goes along with Zorg, which also relies on pip for package management and for just generally distributing the source. So we have actually looked into MicroPython, and I have looked into obtaining a board, though I've not yet been able to. But it's definitely something that it complements Zorg instead of fully replacing Zorg, and Zorg does not fully replace it.
This would probably be a good time to dig in a bit to how Zorg is actually implemented in some of the design choices that you guys had to make in the process of building it.
Sure. So Zorg uses an adapter pattern, which actually ends up working out very well for projects like this. It wasn't actually our decision to use that. We kind of discovered that was how the hybrid group was designing their robotics frameworks. The hybrid group, for anyone who isn't familiar with it, they designed 3 different robotics frameworks, one written in Go, another written in Ruby, and another written in JavaScript. And those are called GoBot, R2, and Cylon. And at the time, we were looking closely at those for inspiration for how to actually properly set things up and get it working. And the power behind the adapter pattern is that it lets you define a single set of code for your device. So a device might constitute something like the Intel Edison, the Raspberry Pi, things like that. And then it lets you create all of your drivers, your devices your other devices, so sensors, LEDs, motors, things like that. It lets you create the code for those separately, and then it promotes reusability because once you have the driver for the initial board created, all you have to do in order to use your sensor code with it is change out the driver you're using. And because they all use the same interface, you don't have to rewrite anything.
Yeah, it definitely is a very powerful pattern, and by not having to change your code when you switch out different hardware underlaying it, it makes it a lot easier to innovate at the concept level as opposed to having to reimagine and sort of rework the code if you want to start running on a different hardware platform so that different people don't necessarily have to all have the exact same hardware to be able to take advantage of something like Zorg. I know that that's one of the factors that has made the Cylon.js project pretty popular.
Yeah, so I mean, it's basically the same thing. So I mean, if somebody creates a project and it's designed to run on a Raspberry Pi, there's very minimal software changes that have to happen in order for somebody else to run on an Edison or something else. It's very cool because it approaches platform independence at the code level.
And I know that it runs on the Intel Edison, and it looks like there's some support planned for Raspberry Pi and some of the Arduino chips. What other platforms are you currently working to support, and/or which ones are you hoping to be able to support in the not-too-distant future?
So development is currently partially completed for platforms such as the Raspberry Pi and the Arduino. Kevin's done a lot of work with the Raspberry Pi in order to get it working with some of the native Python libraries on there, which is very cool and very efficient to see how a lot of that works. And then the Arduino boards are set up using the Fermata protocol, because unfortunately right now we don't have the ability to run Python on an actual Arduino. Those tend to prefer C and C++, but what it does allow us to do is use Fermata as the standard communication protocol between the Arduino itself and a host computer to actually control it. And that's about the closest we can get at the moment.
Just to add a little more onto that, so I'm the one who's actually in charge of the Python adapter for Zorg, and that's actually very close to being finished. I've got it working pretty much completely with the Zorg platform. I have also invested in my own spare time in a Pine64, which I plan to add support for relatively soon once I actually figure out how to interact with the Pine64's pins through Python. And I've also got a chip, the $9 microcomputer, which I'm also considering looking into supporting on Zorg.
And for platforms like that, what is actually involved in engineering the communication between the Python layer and the actual chip itself? Is a lot of binary protocols, and sort of what are some of the either standard library or third-party libraries that you need to use to be able to actually facilitate that communication?
Zorg works as a layer that takes different libraries for interacting with platforms, and it gives them a consistent interface for communicating with them. Which is very helpful because, for example, the Raspberry Pi and Intel Edison have completely different built-in libraries for communicating over Python. But with Zorg, we're able to actually make that consistent across both platforms with minimal to no extra work required for actually porting code between the two of them. And what's fun about Zorg and what's very useful is that as long as there's actually a library already available for using Python to communicate with the platform, it's very simple to build a Zorg adapter for it, which means that we aren't that often dealing with binary protocols and actually reverse engineering how we're supposed to communicating on the hardware level, as long as we've already got the library support out there. And what's nice is that for a lot of the popular platforms, the libraries do exist because Python is a popular language. And by adding Zorg to them, we got the platform independence that comes with Zorg that allows us to actually interact with devices across them so that people don't have to do that manually.
And going back to what you were saying about the Arduino and needing to have a host computer, how frequently do you see people using Arduinos where the host computer is something like the Intel Edison or the Raspberry Pi as opposed to actually tying it to a desktop platform?
I've actually seen that quite frequently, primarily with libraries such as going back to Cylon.js again. But I've actually used it a number of times that way myself, just to get that platform slightly more mobile. The benefit of that is that a lot of times the Arduino you can get one for extremely cheap, under $5 in some cases, and it adds a really good way of adding a number of input and output pins onto the typical ones that are available on the Raspberry Pi.
And I imagine that would also make it a lot easier to offload some different logic routines onto the Arduino as opposed to having to keep them on the CPU core and tie up some of the processing cycles that are available to perhaps do other things.
Yep, no, definitely. It allows you to start delegating tasks to some of the other devices, which is always a help when it comes to processing power.
And is Zorg currently useful or actually being used for any production level applications, or is it still primarily intended for educational or hobby projects?
So I'm not aware of any production applications that are currently using it. One of the kind of design philosophies that we wanted to go for with it was looking at how successful Python platforms have been for software such as Django or Flask and some of the current web frameworks like that. So we were kind of thinking, the concept behind it is, what if you could create a Python framework for robots, a Django for robots, so to say. The idea is to have the extensibility to have numerous plugins and support for different features available. And it's just a concept that we've kept with us as we keep developing it.
And what kind of plugin system do you currently have in Zorg? So I know that you can plug in the different drivers for the hardware level, but at a higher level, what kind of things can you plug into it?
So an example of that is still sticking with the hardware level, the same architecture that allows you to create a driver that can allow your device to control a servo motor. You can also do things like creating virtual drivers. So I've experimented with creating ones that allow you to have a virtual OpenCV driver. So because there's bindings for OpenCV in Python, it makes it very easy to connect your Zorg application to an instance of OpenCV, and you can do things that treat that new module as a virtual device. So whether or not there's a camera attached or not, directly to what's being pulled in, it can still process images and come up with results. So I guess a good example of that could be a virtual face recognition sensor. The idea is to use OpenCV and a camera as a virtual driver that allows your robot to wait for an event, such as somebody to walk into the room. And so you create a virtual driver that, using OpenCV to watch for a face, and then once that occurs, you can execute some sort of action in response to that.
And what sort of hardware knowledge is necessary for somebody to get started with a project that would use Zorg?
So I'd say very minimal hardware knowledge. We started at a hackathon where we ourselves were learning the Intel Edison, and we've tried to keep the documentation up to date such that someone can, in the same way, just sit down and start learning it. It's designed to be fairly easy to set up and get started with.
So one of the other things that's nice about Zorg is that we do have the option for web API, which we found even in our own testing and at the hackathon where Zorg was developed. We were able to work with other people there who had basic web knowledge and were interested in actually testing out Zorg. They were able to build very minimal apps in a very small amount of time that interfaced with the drivers over a web API, which meant that the web API basically exposed the standard Zorg interface, so that they were able to just make web requests to it instead of actually executing basic Python code. And that's one of the philosophies that we try to stick to with Zorg, is that there should be very minimal work required to get it up and running on the device, as long as we support the device that you're using. And that's something we've tried to stay true to, and I feel that we have so far.
What are some of the most interesting projects that you guys have seen created using Zorg?
So to give a couple examples, I've seen a number of just small autonomous robots created with it. Some more specific examples, I mean, at the original hackathon that we participated in, we designed an automated door locking mechanism. The idea was that somebody, when they approached it, it'd be able to detect them and authorize them to open a door. And so that was just a simple application of demonstrating an IoT device that allowed somebody to interact with the physical world. Other projects, another one is one that I manage. I have a 6-foot-tall humanoid robot named Salvius. The robot's made out of recycled parts, and typically I take it around and do different technology-related talks and demonstrations with it. But Salvius is currently running an implementation of Zorg and using that with several other Python libraries in order to do different tasks.
When I was looking at your GitHub, I noticed that you've also got a voice adapter for plugging into Zorg for being able to do voice-activated interaction with the actual robot.
I don't believe that's that we currently have that on the Zorg repository on GitHub. I have a similar one that I created for a different project. Yeah, it's that is one of the libraries that I use with the robot. So on a different level, it does get some sort of use with Zorg. I have a Zorg driver that allows it to communicate with the eMic2 text-to-speech module, which is it's a nice way of allowing the Raspberry Pi to hand off the text-to-speech process to a different device to have that processed. But the library that I use for the voice recognition, it has several parts, including coming up with responses to what the user is actually saying, and it'll use different machine learning algorithms to figure out new responses based on hearing how the person replies over time.
That's very cool, being able to build up that conversational repertoire just by interacting with the robot, or if you're just using it via text with for instance, a chat room. What kinds of machine learning routines do you use for being able to determine what parts of speech are applicable to the various different conversational contexts?
So right now, the way it works is it represents the conversations internally as a graph data structure, and it uses a couple of different algorithms to come up with different possible responses. So one of those algorithms is the Levenstein distance algorithm, and that's doing essentially a fuzzy match on the text. So it's looking at the current user's input statement and the different known existing possible responses, and it's looking for a simple text match. Another one that it does is it uses the Python NLTK, Natural Language Toolkit library, in order to look at the actual synonyms of different words in the sentence, and it makes a comparison to try to figure out if two statements are basically synonyms to one another in order to come up with the closest match and generate a response.
So, how does Zorg compare to some of the other Python robotics projects that are out there, such as ROSPy?
So for ROSPy, I'd say that Zorg does not. It doesn't necessarily try to compete with it. ROS, the robot operating system, it doesn't necessarily try to replace other robotics frameworks. What's nice about ROSPy is that it allows you to. ROSPy is essentially Python bindings for ROS, as far as I understand. So what's nice about that is it would actually be possible for somebody to potentially use Zorg and ROS side and side. ROS, the whole philosophy behind the project is to reduce re-implementation of different algorithms. So they focus on reusability of their code. And the whole idea is that they modularize themselves, and it would actually make it possible to use different components of ROS within Zorg, or potentially vice versa if one was interested.
So, are there any other questions that I didn't ask that you think I should have, or anything else you want to bring up?
I don't believe so.
So, for anybody who wants to keep in touch with you guys and follow what you're up to, what would be the best way for them to do that?
We're on GitHub underneath the organization Zorg, which is nice and easy to remember. We also have a newsletter that we occasionally send messages to, which you can sign up for on our website, zorg.github.io. That's probably the best way to keep up with us, because that's where we post announcements for the latest developments within Zorg, including new adapters, new drivers, and just interesting things that we found out.
So with that, I will move us on into the picks. And for my first pick today, I'm going to choose the Padlock Password Manager. I have recently been working on swapping out some of my duplicated passwords and using a password manager, and the Padlock is a nice, simple open source option that has both Chrome plugin as well as an Android application. So I've been using that. It's been nice and easy. And another project along those same lines that I started using recently at work is the Vault project from HashiCorp, which is a storage mechanism for being able to keep track of the various different secrets and security tokens and keys for your infrastructure. And it just makes it a lot easier and more well-maintained than some of the typical approaches that people generally use for keeping secrets in infrastructure. And with that, I will pass it on to you, Gunther. What do you have?
Okay, so again, something that I really like is robotics. It's a subject that I'm very passionate about. I'd say that probably one thing that I would recommend most is a book called Robot Builder's Bonanza. It's got a lot of information in it, a lot of good projects and ideas. I would definitely recommend it to anyone who is kind of interested in either learning robotics or just looking at some interesting ideas for different projects.
And Kevin, what do you have for picks?
So I found it essentially is a blog post, but it's got a tutorial built into it for working with OpenCV and Python for facial recognition and face detection. That's been a line of work that I've been looking into for quite some time, and there's plenty of different algorithms out there. This algorithm appears to work properly with the latest version of OpenCV and the Python bindings, which I thought was actually kind of nice, considering OpenCV, as recently as last year, hit a major version release, which made it such that past blog posts and tutorials didn't quite work how you'd expect.
Great. So I just want to say thank you to you guys for taking the time out of your day to join me and tell me more about the Zorg project. It's definitely an interesting space, and I am hoping to spend more time in it, and I'm sure that there are plenty of my listeners who would like to start tinkering around with Zorg for their own purposes. So thank you very much, and I hope you enjoy the rest of your evening.
Thank you. You too.
Thank you.